Hey, hi folks. So today we are going to discuss two sum problem. I know this is straightforward for most folks, but yeah, let's tackle this. So basically, we are given an array of integer nums and an integer target. So we have to basically return the two numbers indices whose values would match up to the target. For example, we are given like 2, 7, 11 and 15. So we have the target pair as 9. So we have two values here, which is 2 plus 7, which is equals to 9. So we have to return the indices of 2 and 7 here, which is basically um, 0 and 1. Yeah. So, and we are also given a small clause here that like we can return the answer in any order. So either the 0 1 would work or 1 comma 0 would work. So it doesn't matter how we are returning these values, but we have to return both the indices. And we're also given in the constraints that only one valid answer exists. So we can be sure that we don't have to think about an edge case where multiple answer exists and which one we need to choose. So how do we tackle the problem? The first thing that comes to my mind is using a two nested for loops uh, to check every unique pair, which is basically like we will check 271's a for loop that runs among like let's say, okay. So I'll have an I value here which runs from index 0 to end of the list, and then I'll have a j that starts at index 1, and it will run from 7 or the I plus 1 to, okay, let me take it like this. So yeah, j will start from I plus 1 to end of the list, end of list, and I will start from 0 to end of list. So for each unique I comma j value pair, and if their values, if the indices of these values sum would be equals to 9, then we will take this I and j values in our result set. Result is equals to I comma j. We will store these I comma j value pairs in result, and finally we'll return the result. So that's one way of handling with this. But one big issue here is going to be the time complexity, because we are taking two for loops, and like we are running this from every unique I comma j pair, which will make the time complexity as big of n square, uh, because 1n is for looping through all the values of I, and the another n is for each particular I. We are looping through the entire other remaining indices, that is from I plus 1 to j, so which will make it a time complexity of n square, and the space complexity is going to be big of 1, since we are not taking any additional space except for the constant indices space, which is like just two indices in a list or array, as we can call it in Java. So since we are also know that like we only have one valid answer that exists for a given problem or for a given test case, so the space complexity is going to be big of 1. But if I think about it, like there is one more way I can solve this, because one thing is like we have a high time complexity and a very low space complexity. So whenever it comes to problems like this, one obvious thing that comes to my mind is, okay, can I take the advantage of low space complexity and take a data structure which can probably store more values, which is basically increasing the space complexity from big O of 1 to big O of n or n log n, to reduce the time complexity. So it's basically a trade-off, right? So that's where I'll be going for. And the first solution that comes to my mind, if I think of, is using a hash map kind of data structure. So basically we can solve this in a linear time by using a hash map data structure to store each number's index uh, as uh, as we iterate through the array. So for example, what I'm trying to say is, so once we will only go through the array once to start off with. Let me just remove this. So what I'll do is, I'll just go and I'll store it in a hash map which says 2, the value 2 is present in the 0th index, and value 7 is present in the first index, and value 11 is present in the second index. Okay, why did I take 1 here? And value 15 is present in the third index. So once I iterate through the entire array, and once I have these values, I can again go into the same array, and I can find, okay, the moment I see 2, the next time I'll see if our target minus our current value, which is array of I, is present in the hash map or not. Okay, if this value, which if our I is 0, then the value is 2. So the target minus array is going to be 9 minus 2, which is going to be 7. This is present in our hash map as one of our keys. So what I would do is, I'll take this particular index, which in this case is 0, and then I'll go and fetch the index of the target minus array of I, which is the target of the index of value 7, which is going to be 1, and I'll simply return this set. So this way what I'm trying to do is, I'm taking an extra space and I'm basically reducing the time complexity here. So that's what I'm going to do. And a slightly more optimized version of this is, like, instead of taking a loop 2 times, what if we can just go through the array for first time, and whenever we find a value, for example, in this case, the moment we completed iterating the first index, which is 0th index, which is value 2, we will increment I, right? So whenever we find the new index, we move to the new index, we will check whether the target minus the current index's value is present or not. In this case, it is going to be 9 minus 7, and we will check whether this 2 value is already present in the hash map that we have created so far, right? Which in this case immediately returns true, and it will return the value 0, right? So then what I'll do is, I'll simply take I, and I'll simply, which is in this case the index of value 7, which is 1, and the value that is returned by the index value that is returned from the hash map, which is 0 here. So since we do not care about the ordering of these indices, like either 1 comma 0 should work fine, or 0 comma 1 should also work fine. So that's my total approach, the best form of approach that I could say for this problem. So that's what I'm gonna do here. Yeah, so let me start off by taking hash map of integer uh, comma integer, and I'll probably call this a map, and I'll take a hash map here. Yeah, this will basically have the value pointed to the index of this particular value in our current nums array, right? So once we have this particular hash map that is declared, I'll just use a single for loop, which is basically for int I is equals to 0, I is less than nums dot length, and I'll simply iterate through the entire array, and I'll probably take a complement value, which is int complement is equals to kind of target minus nums of our current I, which is what we plan to do initially, right? For whenever we go to a new index, we want to check if the target minus our current index, that is the new index's value, is already present in the hash map or not. So that's what I'm doing here. Like, I'll take the complement value, and I'll check if the complement value is already existing in the hash map. That is, if map dot contains dot sorry, not contains dot, it's contains key of complement, then what we would do, we would simply return new integer of map dot get of the complement, and we will also simply return the current index I itself. So basically we are getting the index of the complement value from the hash map here, and we are also adding I, and we are basically returning array of these two values here. And I hope that makes sense. And yeah, if not, we'll simply put these new index value that we have seen into the map, which is map dot put of nums of I comma I. This will basically add a new key value pair into our hash map, and even by the end of it, like it always says the even though the question says that there was always an existing pair whose sum would be equals to our target value, if we still don't get it, I'll likely return a null value. This is something that I want to talk to my interviewer if this is an interview. This is a problem that I'm facing at the interview, that like, hey, I know that like you have already told me there will always be an answer, but if there is none, I'll probably return a null value here. So I hope my interviewer agrees to this, and if so, yeah, it's all good. So I have run the test cases here, example test cases, and I'm gonna run it through the entire suite of test cases. Yep, looks like they're passing, and as we have already discussed, the time complexity is going to be big O of n, since we are just iterating through the entire array once, and the space complexity is going to be big O of n as well, because we are storing up to n elements in the hash map, right? So we can probably, I mean, we might find the complement value as our last index in the nums, right? So for that, we have to iterate through all the elements in the nums array until we go to the final element to find a possible two-sum pair. So in that cases, the space complexity is going to be a big O of n, which can take a maximum of n elements. So yeah, that's going to be our solution for this problem.